challenges of multi-environment infrastructure. Let's just go through a journey for a little bit. Talk about how we get to multi-environment infrastructure. Well, first, you start out with some devs. They have a laptop. They have some servers. So you have two environments, dev and prod. You push code from your laptop into your servers. Everything's fine for a little bit. Then you add a bunch more developers. Things get a little hairy. You start to add some tooling to make this a little bit easier. So you add some shared Git repositories to control your source code. You add Jenkins, because you're no longer SSHing from your laptop. You let Jenkins do the SSHing, because you're smart. And then you add an identity provider, right? You need to manage identity across all these folks and have ways to control what they have access to. So we're getting a little bit more complex here. But we also added another environment here, because we have a lot of developers that are trying to integrate their code. So we added something between development and production. We added this staging environment. So we see these logical environments being built, all maybe in the same data center or cloud provider. Next, we start adding even more developers. We actually hired a security officer, which is awesome. They started to see a bunch of our database credentials in environment variables, and they decided to add some more tooling. They added HashiCorp Vault to manage our secrets across our company. Then eventually you decide to move into a cloud provider, maybe GCP. How many folks are already running on GCP here? Yes, love you guys. So you add more logical environments as well as you're replicating staging and prod potentially, but you're also adding an entire different physical location, right? A cloud provider's region on top of what you already had. And you might start looking at, going from VMs to something like containers. How many folks are doing containers or Kubernetes in general? Yes, a lot of you, right? Welcome. So what are some of the challenges that we see as we kind of go through this journey? Well, first, we're deploying different ways to different environments, whether they be logical or actual physical different environments. We see that our environments, like staging and prod, are starting to drift a little bit. They don't actually look the same, so we're seeing a lot more things creep into production that we didn't really expect because we thought staging was going to catch it. We have trouble managing access control. There's different ways to access different pieces. So you start doing broader and broader permission sets, and people can have access to things that they shouldn't have. You also have networking complexity. Now you have to actually go and connect these multiple physical environments, maybe through VPN, interconnects, things like that. Things get tough. You have to manage IP addresses now. Finally, you have built up a lot of tools that maybe don't work well together or work well with the infrastructure providers that you've put in place. So you have to start integrating these things. You can't just throw it all away. Sometimes you wish you could, but it's been baked into your organization. So you need to start thinking about how to integrate these things. So this is kind of the view that we had in the last few slides. We have a lot of logical environments and some physical environments that we're thinking about. What we want to do is build a consistent platform out of these. So you ask yourself, what is the platform? And it's essentially everything except for what the developer needs to do to push code somewhere and get it running. You want them to be able to have the same experience whether you're in 60 different environments or 3 different environments. They push code. They monitor some sort of deployment process, and then eventually their code gets out to customers and starts providing value. How many folks have seen this gentleman before? Kelsey Hightower. Yeah? Awesome. There's a tweet from Kelsey for every single talk I've ever done, and this is the one for this talk. Kubernetes is a platform for building platforms, right? It gives us the starting point to get an abstraction across our environments. And now we'll talk about how we can get there with Kubernetes. So you'll have different layers to your stack. You'll have an infrastructure layer where you have disks, compute, networking. You'll have a platform layer where you have these tools that make it easy for developers to get their code out into those computers and networks and so forth. And then you have your applications. These are the things that are actually giving value to your customers. And so here's kind of that view of our old, our previous diagram layered into these stacks. So here we have Kubernetes providing an abstraction above infrastructure. In GCP, that's our VPC networks, our load balancers, our disks, monitoring, logging, all these things that we have to, in the past, use individually. And you can also use these across cloud providers and even on-prem. And so then on top of that, we use that Kubernetes API to deploy our applications. And you add tools like Jenkins for CI and Spinnaker for CD. You store your repositories in Git, maybe GitLab or GitHub Enterprise. And then you provide applications to your users. So what are some of the benefits of using Kubernetes at that infrastructure layer? Well, first, you get a consistent deployment platform that provides you a single API or set of APIs that you can use to manage your workloads. Right? When you want to deploy something, you know how to deploy that using an API or a declarative API. And you get the same type of deployment process when you want to upgrade. So a rolling update or a blue-green, you do that one way across all of your environments. Finally, this Kubernetes API is available as a managed service across all of the cloud providers. Right? So you can instantiate Kubernetes clusters in each of them and even instantiate them on-prem with GKE on-prem. So now you have this one workload API that you can point your deployment tools at to build your platform. So now we've built this platform. We have this abstraction for deploying to Kubernetes. But one of the things you'll notice as you start onboarding to Kubernetes is you have YAML and YAML and YAML and more YAML. How many folks deal with YAML on a daily basis? Lots of us, right? This gets really challenging over time. There's a lot to think about. There's a lot of APIs to know. There's pretty good API documentation out there, but you need a strategy for managing these manifests across the environments. So one way to do this, to kind of sum up what a Kubernetes application is, or the deployable unit, it's a lot of these different APIs stitched together. The pods are dependent on a config map and a volume. The services depend on pods and their labels and so forth. And they're all defined as YAML. So what do we really want to do? We want to have some base configuration that then we can add and sprinkle in some environment-specific configuration on top of, keep that minimal as possible, create a deployable manifest, and use that to deploy to our clusters, whether that be through kubectl or through Spinnaker or whatever. This is kind of our end goal with manifest management. One way to do this is with Helm. Do we have a lot of Helm users in here? Yeah. So Helm can be seen as a templating engine for Kubernetes manifests. It's got a really large community. And if you're looking for examples of what it looks like to manage an application with Helm, you can go to hub.helm.sh. There are over 500 applications that are deployable today into your Kubernetes clusters, and you can see what the patterns are within there. It allows you to use loops and conditionals within your templates. I'll say that this can be challenging as you are now in a Turing-complete templating language mode. So as people add complexity to your templates, you're going to start to lose visibility into what each change actually does. And I've experienced this as a chart maintainer. Sometimes I just have no idea what a single line change in a Helm chart will do to a larger kind of multi-file, thousands of line of YAML template, right? The reason I first got into Helm was because it was really familiar for me. I came from the world of Chef and Ansible and knew templating pretty well and knew how to work with it. So that's where I came from, and it felt really familiar. So it's a good place to start for those folks. Helm, if we go to that kind of base plus environment-specific config plus rendered manifest methodology that I mentioned earlier, Helm allows you to define a template. And so you see those bracketed values here on the left side. I have my values.image and my values.log level templated into the YAML. And then I provide what I want those values to be templated or rendered into, and then it spits out a template or a rendered template for me. I can use the Helm template command in order to do this, and it just spits out the raw Kubernetes manifest for me. Another way to do this is using a tool called Kustomize, and it takes a little bit different of an approach. It adds patches to Kubernetes manifests. So you bring a normal, untemplated Kubernetes manifest, and then you apply patches to that manifest on top of it. It also can provide tooling to add labels across all of your resources, or add a prefix to all your resources. You might add staging to the front of all of your staging manifests, for example, and it makes it really easy to do that. Another benefit of Kustomize is that it's baked into kubectl as of 1.14. So if you install kubectl 1.14, you already have Kustomize available. And taking a look at the model for Kustomize, you can see on my base, I don't really have any templating in there. I could apply this into a regular Kubernetes cluster, and it'd probably work. And then I add my patches. So here, what's important to know is that you have to tell Kustomize which thing you're patching. So you'll see my patch in the middle actually calls out the pod, my app pod, and the container that I'm going to change. And my change here is actually changing the image from busybox to busybox:dev, and does the same thing, renders me out a template. So on the right side here, you see the customization configuration. It's called a customization YAML. And you can see I add some common labels, a namespace that I want applied to all the resources. But the core of it is I say, where's my base, or where are my base manifests? And then which patches do I want to apply on top of that? Previously, you might have done a kubectl apply-f. In order to use Kustomize, you have a customization YAML in your local directory. Use kubectl apply-k in the local directory, and it will render and apply the correct manifests. The next thing I wanted to do was show kind of an example of reusing as much of your code as possible, or as much of your YAML as possible across your different environments. So you can imagine a company that is heavily Java-based or has a lot of teams that are doing a lot of things in Java. So they create a base that is how they would run Java. This may include setting some standard XMX parameters, where logging goes, some weird -d flags. I don't really do Java. But you have a lot of weird stuff that you bake into this Java base. And then from there, you have different customizations on top of that Java base that create an application base. And then from there, that application base can be customized further for each of the environments that you're in. So you're trying to reuse as much as possible as you go through, so you really know how much or what the changes are going to be as you work your way through. So now that we have a bunch of YAML that we could deploy, we're next going to bring on Ben Good, who's going to tell us all about how to actually deploy this really good rendered manifest.
Okay, so before we get too far down into how to deploy, let's remember where we came from. So back in day 164 or whatever, Vic showed us a picture kind of like this. And we were using Spinnaker, or Jenkins rather, to deploy our code out from our CI system into our various environments. And we probably added in some Chef or some Ansible or something like that to help us keep our environment configs as stable and similar as possible. And then at some point, we said, ooh, this Kubernetes thing is really cool. So let's do some Kubernetes. And at that point, your CI pipeline is pretty similar to what your application pipeline was. You're just changing from building application binaries to images. But what's different now is how you do those deployments. So now you're using shell scripts to run kubectl commands to get your code out to your various environments. At some point, hopefully not too far from that point when you're using shell scripts to do those deployments, you realize I could really use a tool that's going to help me see how my deployments are going in a more Kubernetes-aware, Kubernetes-centric sort of way. And that's where Spinnaker comes in. So in Spinnaker, you get the benefit of Kubernetes awareness, as I like to say. So you get visibility into your replica sets, information about how your pods are performing, if they're healthy or not. In Spinnaker, your Kubernetes clusters are first-class citizens. They're just called accounts in Spinnaker. So Spinnaker knows about those things, and you can use resource annotations and then even do automated rollbacks to really manage your deployment pipelines across all of your environments. So a sample Spinnaker pipeline might look something kind of like this. And it's going to vary for everyone depending on the complexity of your applications, how many microservices you might have. But in general, what you're going to do when you start a deployment is to deploy a canary, so a new version of your application. You're going to test it, make sure it's working the way you expect it to from a feature, functionality, performance standpoint. Validate that thing, and then roll it out to production or to your staging environment, whatever your deployment target is. The canary validation could be a manual action where you say, looks good, and you click a button. At some point, that might introduce too much latency into the process. So you might want to look at a tool like Kayenta to automate the analysis of your canaries. Some important things to consider when managing your pipelines. So treat your pipelines as code. I hope that there's one thing you take away from the deployment portion of this is that your pipelines and your CI/CD processes are really just code when it comes down to it. So if you're applying GitOps principles to your application code, do the same thing for your application deployment pipelines and build processes. try to leverage a tool like Istio, so that way you can really understand where your traffic is heading and how much traffic is hitting your canary versus your running deployment. And then use the same pipeline across all of your environments. So whatever you do for production deployments should be the same kind of process as you for staging, QA, whatever pre-production environment you might have. Wrong direction. Okay, so in a single cluster rollout, we have our shared tools cluster up there, and you start your rollout by going to your staging environment, deploying your canary, and once when it's validated, you roll it out from there. Same kind of thing for your production environment. So you deploy your canary and then roll it out from there. On the other side of the slide are some deployment strategies that you could use, but typically you find yourself in the rollout scenario because it's more resource friendly. Okay, now let's think about this from a multi-cluster perspective. So because Kubernetes is a cross-platform tool, you can be running GKE clusters, you can be running GKE on-prem, and you could be running Kubernetes in some other cloud. And that introduces several complications to the scenario here. Notice in the slide we have two GKE clusters that look pretty similar, but they're in different locations. We have a GKE on-prem with a different version of Kubernetes and another cloud provider out there with yet another version. And you have to think about how your application behaves in those scenarios, and then also about how your interconnects are happening there, because they can introduce variables into the scenarios. So again, with Spinnaker, you can chain your rollouts, your deployments. So you start with a single cluster, deploy your canary to that one cluster, and that one looks good, then roll it out to the rest of the fleet in that cluster, and then move on to the next one. Maybe your monitoring and your tooling is sufficient that you can do your canary rollout to every cluster all at the same time, but understand that you're looking at the results from your canary deployment in the context of many other variables at the same time. So, but the important part is to canary on each one because those differences could have an impact on your application, and also to use the same process for each cluster. So once when you have your application out there, you also need to be thinking about how to manage traffic across those clusters. So Istio is a good tool to use for managing your intra-cluster within one cluster or across your clusters, or also known as your east-west traffic. The other thing that's really helpful to do is to manage your north-south traffic. So how much traffic you're getting from the outside to a particular Kubernetes cluster. And tools like Cloudflare or Akamai or Fastly, something like that, can help you manage that traffic. And that allows you to cluster, to canary your application at the cluster level. So you could do this upgrade that's shown on the slide and know that that new change isn't going to impact your application. So once when all those things are in place, you're in a pretty good position to handle changes to your environments and to your Kubernetes clusters. For example, GKE has this awesome little upgrade button. So when you upgrade, it goes out and it rolls out the changes, the new versions of Kubernetes to all of your masters and worker nodes. And that's awesome. It's a great feature. But that also introduced changes in the API, and if that does cause a problem, rolling back is hard in that scenario, or could be hard. But having the ability to control your traffic flows and what versions of your applications are deployed where is very useful. Also, like I mentioned previously, Kubernetes clusters are built in and first-class citizens in Spinnaker. So they plug right in relatively nicely. Karl's going to touch on this in a little bit about some of the nuances and challenges there. But they fit in pretty nicely. And then also, Don't forget that shared cluster up there with all of your Jenkins and your Spinnaker, your Vault, whatever those shared tools across your system. Be sure to treat all that stuff like code, keep it in source control, and also try to store your artifacts from those processes out somewhere else, not on the cluster. That keeps you out of the pet cluster scenario that we hope no one finds themselves in. And the Google Cloud Storage plugin is a pretty good way to go about doing that. So now I'm going to turn it over to Karl.
Thank you. I'm Karl, and I work at Cruise. And Cruise is building self-driving vehicles to safely connect people to the places and things and experiences that they care about. So we're primarily building a self-driving car fleet in San Francisco right now. This is one of our open source tools called Worldview. Allows us to see what the car sees and be able to reproduce its functionality. So I work on the PaaS team, so I don't work on the car itself, mostly just on the cloud backend stuff. A lot of the stuff that I deal with has to do with the multi-cloud infrastructure that we have at Cruise. We have a hybrid private cloud internet, or network rather, that spans on-premise, GCP, and AWS. We have things on-premise that need to be on-premise, like ingestion from the car data. We have stuff in GCP that makes sense on GCP, like GPU and machine learning and GKE. We have stuff on AWS that we've had on AWS for a while and that makes sense on AWS based on their strengths. So this is just a sampling of our sort of multi-cloud infrastructure and the variety of workloads that we're running. It's kind of wider than most places that I've worked at. So in order to make this work on GCP, which I'm going to be focusing on today, we ended up splitting up our projects and our folders in order to separate them on environment lines. We have environmental folders at the top level of the organization in GCP, and then we also separate the networks along those lines as well to provide isolation between development and staging and production. So if someone compromised development on some CI from open source tooling or something, they don't have access to the production clusters or the workloads there. So it adds a little extra security, a little reduction of blast radius. And what this means is that we're setting up multiple projects per team at this point. So for example, NetEng here has a shared private network spanning multiple environments, and they share that network with the other projects. And we have different teams that have, for example, their databases in SaaS products and other things like Cloud SQL, other SaaS products in GCE, whether they're running GCE nodes or GCP SaaS. And then the PaaS team manages a set of shared clusters across the environment here. So in order to make this sort of multi-tenancy, multi-environment workload or spread work in GKE, we also spread these environments across the GKE namespaces. So we use GKE namespaces for a tenancy that is not necessarily full multi-tenancy, but also not completely unisolated. So we have these clusters in these different environments, and we have namespaces allocated to different teams across those clusters. So a different team would use continuous deployment, for example, to migrate their application from development to staging to production as it increases in stability. So a couple of security challenges that's presented to us is that when you're not using one Kubernetes environment or one GKE environment, you have to figure out how to make sure that your enterprise identity provider and your single sign-on and your service accounts and your credential rotation and your bootstrapping of your project works across those clusters. And effectively what that meant for us is that we had to go from managing a whole bunch of clusters to managing a smaller set of clusters with having a platform team that managed those so that we could centralize that experience so that we could level up the experience that everybody had. So there's some other security concerns around encryption that I'll get into in a bit, but basically you need secret management and secret injection and some kind of caching for secrets sometimes, and you need to manage TLS across your clusters. If you have it in more than one cluster, it becomes a little bit more of a headache to manage externally. So this is one of the things you might not think about when you start going into multi-environment, is that multi-environment really probably means multiple GKE clusters. And when you're thinking multiple GKE clusters, you can't centralize everything in the CRD level. You can't centralize everything in the Kubernetes layer. It doesn't make sense to store the source of truth in one GKE's secrets. You probably want to externalize those and then replicate those to your GKE clusters. And then we have a whole bunch of complications around access control, around group management, and role binding, which I'll get into in a bit. And then also like service-to-service authentication and access control is a little challenging. User-to-service, user-to-platform, user-through-service. All of these are things that you might not think of right up front, but you'll have to solve sooner or later. So one of the things I wanted to focus on that sort of challenges from the security perspective is Vault infrastructure. We chose Vault early on, partly because we were already using it, and partly because we wanted to externalize, like I was saying, the secrets management outside of GKE. We do like GKE secrets, but they're a little sort of coupled with namespace permission boundaries, and we wanted to bind them externally to that. So a couple of the solutions that we targeted here was a Vault login through Kubernetes service accounts. So you can use your service account in Kubernetes to log into Vault, and that means you have to authorize that service account with permissions in Vault, and that's managed externally. And then also, if you want to sort of go all the way into secrets management here, you have to get into either secrets injection or secrets caching. We went with secrets injection, and that meant using this model on the left, which is an init container that we wrote, or you can write pretty trivially, that basically reads from Vault, logs in with the service account, downloads the secrets that are configured in environment variable, stores them in an in-memory volume so that they're not written to disk, and then the app container slurps them in. So this is a little different than environment variables because you have to read them from disk, but it's not too hard to read those in from like a bootstrap or an entry point in your Docker file in your container. So basically this lets us do sort of a lift and shift where we have a container that doesn't know about Vault and then inject the secrets into it. But an alternative way is to make your container Vault aware and pull from Vault at runtime. That's also an option which we have used in a couple scenarios. So GCP service accounts is another integration in Vault that we've enabled and configured, which allows us to log in from the container with my Vault credentials to ask Vault for a GCP service account. And then it asks it for specific credentials that are generated with a timeout. So your application gets credentials to talk to GCP to, for example, talk to your database in Cloud SQL, or talk to your SQL in big data or something like that. So we use the sort of host of this solution, and there's a couple other ones. There's like an AWS integration. There's several other pieces, and Vault is very powerful. But what this ends up meaning is that you need to do a little bit of Vault policy management. So we ended up with a sort of convention around Vault namespacing that matches our GKE namespaces, which matches our GCP projects. And it means that your applications are stored, or the secrets that the application use are stored in Vault in a place that is namespace aware, that's environment aware, and it's application aware. So what this allows you to do is, for example, have a team admin or team members that go and have permission to read and write and delete secrets on all the environments. Sorry. And then you can have other people with read permissions to those that don't necessarily have access to see them, but can just list them to show that they exist. And then you can have the application that only knows about its environment's specific credentials. That way you're not leaking credentials across environments. One of the nice things that this provides us with is it means that our continuous deployment solution doesn't need to know about the application secrets. It means the application developer can update the application secrets independent of the lifecycle of the application, and it means that your continuous deployment doesn't need to be authorized with Vault. So a couple of challenges that we went to, I'll just sort of categorize and bucket these. Image building and deployment is sort of a problem you need to solve everywhere. And if you solve this in a multi-tenant environment, it's a little more complicated. If you solve it in a multi-environment scenario, it's not necessarily much different. The way we went with is having a GCR that's central to the PaaS team that hosts GCR. But what that means is that because the boundaries for security are around GCR, That means everybody who has access to push or delete to that GCR also has permission to delete other people's containers that they've pushed into that GCR, which is a little bit of a security risk. So you can either centralize this, or you can spread it out, delegate it to the teams so that each team is hosting their own. But if you do that, then you have to install a pull secret on all of your containers, and if you're, or sorry, on all of your clusters. And if you're running multiple clusters, that can be a little complicated. So around application operations, some of the things that GKE doesn't really provide you with here have to be solved whether you're in one environment or not. That includes DNS configuration, TLS configuration. Structured logging will automatically get converted by stack drivers, but you have to actually emit structured logging from your application. Using the right metrics library is also important for Stackdriver, and in our case, we use Datadog to emit our logs to Datadog, because that's where we were conventionally aggregating all of our data. And then around lifecycle, this is where we get back to continuous integration and continuous deployment. The sort of templating and cloud development environment, we allow people to develop locally, but we find in general people prefer developing in the cloud. So they have more resources available, it's more like production. They don't have to have a beefy machine, they can just do it on their laptop. So we provide a cloud-hosted dev environment, we host a staging environment, which we allow use for both near-prod deployment and load testing. And then integration can either be spread across dev or staging, depending on where your CI is located. With the use of Spinnaker, you can get approval gates. Blue-green isn't quite supported yet, but deploy targets is. And then account management, I'll get to up in a minute. So one of the solutions you can get to for image building is to use Knative build. We're not quite using this yet, but we prototyped it. And one of the things we like about it is that unlike the rest of Knative, you don't need Istio to use the build portion of Knative. And so what that means is that you can get a CRD to push builds as CRD YAML files, and you can do that from CI, and it'll push the build from permissions that Knative build has into your GCR, and that means we don't actually have to give out GCR push to any of our developers. So what we've done is we have a dev GCR that anyone can push to, and then we have a prod GCR that you have to have a service account to push to or push to from a build environment. Another thing we did was we've been using Spinnaker for a while, and one of the things we realized that it was a real pain to add new accounts. So when we got to this multi-environment, multi-tenant system, and we had like somewhere between 3 and 20 clusters, and then we decided, you know, I don't want everyone to have cluster admin to deploy into whatever namespace they want from Spinnaker. We actually had to isolate that down. So now we're spitting out Spinnaker accounts by like 20 per cluster. Which meant we needed a new way to manage this because each new account requires a reboot of Spinnaker, redeploy because the admin configuration is in YAML, or JSON actually, under Halyard, which manages Spinnaker. So what we did was we wrote a Spinnaker operator. And the Spinnaker operator basically just manages your accounts and manages the lifecycle of Spinnaker itself. So this is not yet open source, but we're leaning that direction, and we're going to use it in production for a little longer to make sure we vetted it right, and then we're going to probably put it in open source in the following months. Some other networking challenges we ran into, DNS I mentioned. Public DNS turns out to be pretty easy, but when you start doing private networking or hybrid private networking, you have to worry about private zones, which is like a brand new GCP feature. And then private DNS from the cluster, you have to start worrying about if you're going across interconnects or VPNs, you have to worry about configuring the IP mask on your kubedns or your core DNS, depending on your config. And this allows you to propagate the IPs from multiple networks. Otherwise, all you know about is the GCP networks. For Ingress, I'm going to go over a pretty complicated private Ingress solution in the future, or in the next slide. And public Ingress, we mostly just use GCLB. However, you have to supply your own TLS and DNS. For egress, public egress, private egress, goes through, if you have a private network, it goes through your VPN or your interconnects. You have to set up your cloud router to basically configure IP propagation across the clouds in both directions, which is a little complicated, especially if you start getting into multiple networks per GCP and multiple clouds and on-prem, and I'm glad we have a NetEng team. Public egress, though, we previously deployed our own NATs with Terraform because that was the recommended solution on GCP. There is now a cloud NAT solution that is beta, GA? I think it's GA. And so we are switching to that. But what it means is you have to put network tags per your regions, because if you are in the same network with the cloud NAT, by default, all traffic goes through that cloud NAT. And if you have two cloud NATs in two different regions, they start egressing across regional lines, which is bad. So you have to start setting network tags on your nodes to make sure they hit the egress traffic. So this is just a few of the little complications that we ran into, and hopefully we can avoid you from running into them 6 months down the line. So I talked about private ingress. We have 2 of the 3 of the pieces of this solution built out and have for a while, and it works okay, but we're not in love with it. The GCE cloud provider here, this is built into Kubernetes, and it knows about GCP, and it configures the ILB, the internal load balancer in GCP, and that allows you to do, I believe, TCP load balancing. It's a layer 4 TCP load balancing. However, what we needed was an analogy or something analogous to our public load balancer, which does TLS termination. So what we ended up doing was putting Nginx controller behind that. So we have ILB routing to Nginx, Nginx does termination, and then we handle the traffic internally, and then we're working on deploying Istio to do the end-to-end internal encryption. But the last mile still exists. You still have to handle DNS, like I mentioned. There's an external DNS project that we have on our backlog to look into. It can configure the private DNS or public DNS in GCP for configuring those. But it becomes a little more complicated if you have a private network. For example, we've been using Route 53 for private DNS resolution, and that works great on AWS, but in order to get that into GCP, we have to route through the interconnect to resolve all your DNS connections, and that's a mess. So we ended up caching that on the GCP side, and we're looking into a more like DNS mesh solution where we have some Google Cloud parts and some AWS parts, and they like mesh together so that they have multiple sources of truth for the DNS. So external DNS won't solve all of that together, but it'll at least help you provide your, or provision your private DNS. So the benefit of this solution is that all 3 of those components can be set together with Kubernetes configurations. So this is self-service to the user. The user can say, I want private DNS, or I want private ingress, or I want public ingress. And I configure that at the same time I deploy my application, which means that I, as a PaaS owner or a cluster operator, don't need to care about how people are doing ingress. I provide some solutions, and they opt into them. All these logs are available to them, and they can opt into them with an annotation. It's pretty slick. So we do have some operational challenges as well. When you are in multiple clusters, whether that's multiple environments or multi-tenancy, we have to figure out whether you want to aggregate or separate your metrics and your logs. So by default, GKE logs and metrics go to Stackdriver in the same GCP project. We didn't necessarily like that very much. So what that meant is we had to give view permission to all of the users on our shared clusters. And we didn't want to give them write permissions because they were our PaaS projects, and they would step on each other's toes. So what that meant is we had to sort of invent a solution that would emit logs to other projects. So we have a Stackdriver Fluentd solution that will emit a duplicate of the logs to the projects that they own so that they can do log to metric conversion, and they can also do log dashboards or log metric dashboards. For logging, we mostly just use Stackdriver. For tracing, we use Datadog, like I mentioned. For uptime checks, we use Runscope. So one of the benefits of Runscope is that unlike most things like Pingdom or other external SaaS providers that will do checks of your applications, Runscope allows you to deploy an agent behind your firewall. So we can do this in the private network, and it does a check of your application. So I'll talk a little bit more about Runscope in a minute, but about availability, we also provide a couple features of the PaaS that don't come native with GKE. That includes backups with Arc, which I believe has a new name that I forget. We also deploy a descheduler, which makes things evenly deploy across the cloud. And like was mentioned, node pool can be upgraded with a click of the button on GKE. Unfortunately, that only upgrades the OS and the Kubernetes version. So if you want to change the instance type, or you want to change node tags, you have to do your own recreation of the node pool. So what we ended up doing was terraforming in a blue-green deployment of node pools, which is a little complicated, but allows us to do zero downtime deployments. We have to have like double the quota we normally run, which is kind of a hazard, but it works. So a little bit about Runscope. We deploy the agents on GCE and also on GKE. We also wrote an operator for this, which again will probably be open source soon. And this operator takes currently Ingress annotations. So these Ingress annotations tell what endpoint do I want to hit, what backend bucket do I want to put them in Runscope, and then Runscope will tell the agent, or rather the agent asks the SaaS product, like, what should I check? And then the agent checks your applications. Sometimes that's going horizontally on the cluster. Sometimes it's going out of the networking back in the Ingress path. Sometimes it's going between clusters, depending on what you're trying to check. So this allows you to check your applications from the full end-to-end path, including Ingress, and not just what Kubernetes does, which is the kubelet on the node checking your pod. As you can imagine, that doesn't really cover much breadth of networking, and usually networking is the problem. So having something that will do a sort of end-to-end smoke test for you every minute or every 5 minutes is super valuable. So we plug this into our local private networking and also public networking, and we have that optional. We're going to be working on converting this to a CRD in the future so that it's not 5 annotations, but that will allow a little more complicated configurations of Runscope tests. And then, so the moral of the story here, a bunch of these operators that I've sort of displayed and invented or worked with my team to build has been about putting your configuration for your operations of your application where your application devs can use it. We have a DevOps model at Cruise where every team that is deploying or is building code is deploying that code, at least on the back end. And so all of our teams want to be able to configure these things about operations, about logging, about Ingress, about metrics. Whether they know it or not, they need access to configure these things self-service if possible. So it creates less operational overhead for us, and it makes things easier for them. They can just go look at the documentation and figure out how to do things. And it makes it easier to do your continuous deployment because your continuous deployment doesn't need to be coupled with all of these pieces. They can be independently configured. This is a link to our Cruise blog where you can see those open source announcements in the future or see our previous ones already. And thank you for coming.